electrochemistry. And in that electrochemistry, we discussed about electrochemical cell, right? And salt bridge, right? We discussed about the reduction potential, oxidation potential, and electrochemical series, right? We did that, right? And we calculated E naught cell is equal to E naught of the cathode minus E naught of the anode. And we calculated the reduction potential of every element, and from that we calculated which substance will be oxidizing agent and which substance will be reducing agent, right? Till this point, if you have any doubt, do let me know. Yes? Any doubt till now? You might have gone through the chapter that I have taught you. Yes, students? No doubt? How to find the ODF cells? What is the ODF? I'm not getting you. Find the product of the cells. Product of the cells means, I think you're talking about the electrolysis part, right? We'll discuss that electrolysis part. That is how to find the product formed at cathode and anode during the electrolysis, right? We have not started with the topic of electrolysis right now, and we'll discuss that part. Okay. So if I have this cell, zinc 2 positive, copper here, right? Can you tell me which is the undergoing oxidation and which is undergoing reduction? Which substance is undergoing oxidation and which substance is undergoing reduction? Yes? Student, you participate in the discussion. Yes. What does the double bar represent here? What is this? Very good, salt bridge. Very good. This is the salt bridge. And to the left of the salt bridge is the oxidation half reaction, and the right of it is the reduction half reaction. It means we can expand this reaction at anode. At anode, what happens? Reduction, oxidation? Oxidation, yes. So this zinc will undergo oxidation. And at cathode, reduction takes place, right? So the copper ions undergo reduction, gain of electron, and become here copper, right? If you add these two equations here, you can cancel out the electrons here. Zinc, copper ions to give copper and zinc 2 positive ion. Yes, student, are you clear about all this what I am teaching right now? How to convert this cell representation into the chemical equation? Yes, right. So if I am giving you the reduction potential of these two elements here, reduction potential of the zinc, yes, we can represent that way also. But this is very clear. At anode means oxidation takes place. Oxidation means loss of electron. It's very clear. This is, I'm giving you reduction potential of copper 0.34 volt, right? So can you tell me how to find the E naught cell now? E naught cell is equal to E naught of the cathode minus E naught of the anode, right? Right. So reduction potential of the cathode. Cathode here is copper. And yes, yes, very good. So 0.34 volt minus 0.76 volt, it is coming out to be equal to 1.10 volt. Am I clear? Yes, am I clear? Right. So this is known as the cell potential of the cell. We call it the standard cell potential of the cell. Why I am saying standard cell potential? Because the concentration of these two half cells, that is one beaker containing zinc rod dipped in the zinc ions, means zinc sulfate solution, another beaker copper with copper ions, right? So this concentration is 1 molar. This is the salt bridge I am putting here, and this is a voltmeter here, right? And the temperature of the experiment is standard condition, that is 298 Kelvin temperature. When the concentration is 1 molar each and the temperature is 298 Kelvin, we say this is a standard conditions, and so we say standard cell potential. Am I clear? Yes, students. Any doubt till now? When I say standard cell potential means under standard conditions. Under standard conditions means temperature is 298 Kelvin and the concentration is 1 molar. Now, if I change the situation here, slightly change. If temperature is not 298 Kelvin and the concentration is not 1 molar, this EMF will not come out to be this much. It means the EMF value changes with change in temperature. EMF value changes with change in temperature. Now, how does it vary? What is the quantitative analysis of this? For that, we have another equation through which we can solve that equation, and that equation is called the Nernst equation. Now, I'll discuss you about the Nernst equation. Right, effect of concentration on the EMF of the cell. So, what is this Nernst equation? This is the E cell. E cell, when I say E cell, it means that it's a cell potential at the experimental condition. At the experimental condition. E naught cell means standard condition. Minus 2.303 RT upon NF logarithm of concentration of the product upon concentration of reactant. Concentration of product upon concentration of reactant. This equation is called as the Nernst equation, and now you can see it is depending upon two parameters here. Number one is the temperature, other is the concentration here of the product and the reactant. Am I clear? Am I clear? Yes, please, student, please participate here. Tell loud till this point. Any doubt? So we can say if temperature changes, the cell potential will change, and if the concentration changes, the EMF will change. This is the logarithm of the concentration of the product to that of the reactant. Yes, Anirudh, are you getting me? This is the concentration of the product upon concentration of the reactant. This equation is called as the Nernst equation. If I fix here temperature, I'm only changing only the concentration only. Temperature I'm putting here 298 Kelvin. R value, you know, it is equal to 0.0821. And F value is 96500 coulomb. To 0.0303, it's a standard condition, right? Yeah, 2.303. And R value is, yeah, you can use here R 8.314. Yes, yes. So upon solving this, it will come out to be equal to E naught cell minus 0.0591 upon N logarithm of concentration of the product upon concentration of reactant. This is E naught cell. So we say E cell is equal to E naught cell minus 0.0591 upon N logarithm of product upon reactant. Am I clear? So what is N here? Can you tell me what is the meaning of N here? No. No, yes. It is the number of electron transferred. Number of electron transferred from anode to cathode. That is how many electrons are being lost and gained in this process. In this previous equation, zinc and copper cell, how many electrons are lost by this? How many electrons are lost by the zinc? How many electrons are lost by the zinc? And how many electrons are gained by the copper ions? 2. So N is equal to 2. N is equal to 2. What the total number of electrons lost or gained by the elements at the anode and the cathode? It is called as a N value, right? Are you getting me? Now, see this equation. For any process to be spontaneous, delta G value should come out to be negative. You know this thing? For any process to be continuous moving, the delta G value should come out to be negative. Yes, can you tell me what is the meaning of the delta G here? What is the meaning of delta G here? Gibbs free energy. Yes, very good. So for a spontaneous process, delta G should come out to be negative, right? And the +1 level we discussed in the equilibrium chapter, that is equal to standard Gibbs free energy change plus RT logarithm of Q, where Q is called as a reaction quotient, is called as a product upon reactant, right? So converting this natural log to the base 10, the logarithm of 10Q. And we know that delta G is equal to minus NFE cell. So it is coming to minus NFE naught cell. Till this point, any doubt here? Let me know any doubt here? No. And now I'm dividing the whole equation with the NF value. Divide the whole equation by the NF. It will come out to be equal to E naught cell divided by the NF. Right? Got it now? Yes. Now let me know if you have any doubt till now. The questions will be very, very simple here. Only beginning and understanding the equation is slightly time consuming here. Otherwise, the questions are very, very easy here. Right. And now, suppose I say the concentration of copper ions, zinc and copper ions are given to you. Right? And I have to find the E cell value. It means that is E is equal to E naught minus 0.591 upon N logarithm of product upon reactant. Product upon reactant. Solid concentration is taken as a 1. Solid concentration is taken as a 1. So 0.1 upon 0.01. Just put the values and solve it. A few days back, I told you how to find the value of the log value, right? Did I? I told you how to find the log value? Yes. So if I have to find this log value, I'll say logarithm of 10 to the power minus 1. And this is 10 to the power minus 2. So it is logarithm of 10 to the power 1. Log to the power 1. 10 log 1 is equal to 1. Right? This is how to find out the E value. Yes, students, do let me know if any doubt. No. Everything is clear? Yes. Okay. So you can see here, very important aspect here. We calculated here logarithm of zinc upon copper. If the concentration of the ions increases at the anode means where oxidation takes place. It means if the zinc ion concentration increases, this value increases, the EMF will decrease. Yes or no? Getting me mathematically? See here, if the concentration of ions increases at the anode means where oxidation takes place. So the concentration of the zinc ion will increase. This whole value will increase. It means something to be subtracted from E naught cell. So the E cell value will decrease. Till now, it is clear now. Now it is clear. Yes, students. This is clear. And now, if the concentration of the ion increases at the cathode means where the reduction takes place. It means if this value increases here. If the concentration of copper ion increases here, if the concentration of copper ion increases here, this EMF value will slightly increase and the EMF value will also increase. Now, any doubt? Getting me? See this equation here. In the previous case, see the previous case. First of all, I will show you the previous case. Zinc ion is 0.01 and copper ion is 0.01. But now, what we have done is, we had decreased the zinc ion concentration and copper ion increased. Copper ion value increased. Now, by calculation, the cell potential will increase by certain value. Are you getting me? Yes, friends. Very clear that if the concentration of the ions at the anode increases, the EMF value will decrease. And if the concentration of the ions increases at the cathode, the EMF value increases. Any doubt here? All clear? Good. So, I am considering a heterogeneous equilibrium here, where one substance is a hydrogen, let it with this SHE. How would I go to know? It should be 0.01 and point. Okay. So that this question, in the question, this value will be given to you. This value will be given to you. I'll be discussing those questions here right now after some time. It is in the pipeline. So you'll be able to understand. So it's a product upon reactant. Product here is a gas here. I can measure its pressure here. Upon H positive ion to the power this coefficient here. Getting me now? So this is the E naught cell value for the hydrogen, that is equal to 0 value. You know how comes out to be 0? Right? Yes, all of you. Are you getting me? How come out to be it is equal to 0? Yes. Oh, Anirudh, you should know that the standard reduction potential of hydrogen is deliberately taken as 0. Standard reduction potential of the hydrogen is deliberately taken as 0. Yeah, you know it. So this is how we can do. Okay, you should know this thing. Previously we had discussed this. So I can write this equation here. If I write this equation, I can write the Nernst equation for this. Product upon reactant. So A naught minus 0.0591 upon N. N value is equal to 5 here. Upon reactant concentration, product concentration upon the reactant concentration. Is this clear? First of all, I am telling you how to write the equation, Nernst equation for a particular reaction. See, H2O is a liquid, and for the liquid, the concentration of the pure liquid or the pure solid is taken as equal to 1. That is why it is now eliminated. Yes, are you getting me? Now we discuss some question based on this. We are given here this equation, right? And apart from this, we should be given one more thing, that is the reduction potential of this nickel. We should be given here, and we should be given here the reduction potential of the silver, right? If you are given this value, then let us solve it. Wait. 0.80 volt and 0.25 volt negative value. These are the reduction potential of the nickel and silver. This value will be given to you for your question practice. Getting me, all of you? Yes, students, are you getting me? Okay. So from here, I can get the E naught cell value is equal to E naught of the cathode minus E naught of the anode. Which is the cathode here? Tell me. Which is the cathode here? Anirudh, I will give you our answer. Yes, it is the monovalent. Yes, you're right. Which is the cathode here? Silver. So I should write here silver. Reduction potential of silver minus the reduction potential of nickel. That is the Ni2 positive to nickel. So 0.80 minus 0.25 volt. So it is equal to 1.05 volt. Getting me? So now we'll be solving for the E cell. E cell is equal to E naught cell minus 0.0591 upon N logarithm of product upon reactant, right? What is the E cell value? E naught cell value 1.05 volt minus 0.0591. Can you tell me what is the value of the N here? Anirudh, Yash, Neha? 2. Yes. Nickel loses 2 electrons and 2 silver ion gain 2 electrons. So N is equal to 2. In the product, we have a nickel ion concentration, and here we have a silver ion concentration to the power 2. Very important here, to the power 2. The coefficient must be now brought to the power. This is a very important thing. Please note it down here. That is, this coefficient should be now to the power here. So 1.05 minus 0.0591 upon 2 logarithm of 0.160, getting me, upon 0.002 to the power 2. Rest remaining part you can solve. Yes, you know how to find the log value of these things, right? Right. So this is how to solve this equation here. Yes, students, this is a very, very important question for your board examination as well as for the competition examination. Any doubt till now? Okay, good. Now, same type of question is this. Check. Can you do it? E naught cell value is already given to you. You can solve. Yes. So I'm showing you. See, this way 0.0591 upon 2 logarithm of product upon reactant to the power 2. This is very important here. This is a 2 here, and I'm making the power 2 here. Yes, students. Any doubt till now? Ask me now. Ask me now. No doubt. Very good. So here we have a different type of question here. See this equation. E naught cell value is already given to you. Cell representation is given. Yes, Anirudh, what is not clear? 0.0591. This value? Okay. I told you this value is basically 2.303 RT. The multiplication of all this is 0.059. Is that clear, Nirud? Yes, Nirud? Not clear? If I multiply here with the 2.303, R value is 8.314 and temperature is 298 Kelvin. If I multiply all these values, it will come out to be 0.0591. 591, more appropriate. Okay. Okay. Now, here we have to find out this H positive ion concentration. Rest is all given to us. If I find the value of the H positive ion concentration, I can find out the pH value. You know the formula for the pH. pH is equal to negative logarithm of H positive ion concentration. So first of all, what we do, we convert this like this. At anode, this hydrogen is converting into 2 electrons, right? This is at a 1 atmosphere. And at cathode, Cl negative ion loses here 2 electrons here and becomes Cl2 gas. That will combine the mercury to form HdCl2. Are you getting me? I am splitting this representation into the reaction part, oxidation half reaction and the reduction half reaction. And E naught value is already given to you as a 0.55 volt. 0.55 volt. And now I can write the Nernst equation that is equal to E cell is equal to E naught cell minus 0.0591. N is equal to 2 logarithm of product upon reactant. Product is here Cl negative ion concentration upon reactant is sorry. If you add these two equations, the product will come out of the H positive ion here. So H positive ion to the power 2 and this is the Cl negative ion to the power 2. Right? This value to be determined. Rest all values are given to us. This value is now 0.55 minus 0.0591 upon 2 logarithm of the H positive ion here to the power determined and Cl negative value is already given to you as 1 molar. Four electrons will come in added equation. How come to? Wait. No, friends, only 2 electrons are there. Only 2 electrons. See here, in my calculation also it is 0.2 only. Only 2 electrons. Yes, how can you say that it is equal to 4? How can you say it is equal to 4? Is everybody clear? Okay, previous page. Okay. Okay. Here I have written something wrong here. this substance is undergoing oxidation, then this substance must undergo reduction here. It should be written opposite. How to analyze the equation? Okay, you should know here. See, this is the salt bridge here. This is the oxidation. This is the reduction part. Left hand side is the oxidation half reaction, and this is the reduction half reaction. I hope now it is clear, right? Everybody clear? Right. So once you get the value of the H positive ion, you can get the pH value. Right. This is a slightly different question. Practice upon this. Calculate the potential of hydrogen in contact with its solution whose pH is equal to 10. So basically, it's the H positive ion gaining electron and becoming H2. And when I say pH is given to you, that means negative logarithm of H positive ion concentration. Right? pH value is equal to 10 is given to you. It means the H positive ion concentration is equal to 10 to the power minus 10 molar. Is this clear? Are you getting me? When we are given here, the pH is equal to 10. pH is given as pH is equal to 10. It means the H positive ion concentration is equal to 10 to the power minus 10. And for this equation, I can write the Nernst equation, that is equal to E cell is equal to E naught cell minus 0.0591 upon N logarithm of product upon reactant, right? E cell value is to be determined. E naught cell value is 0. We know that the reduction potential of hydrogen is 0 minus 0.0591 upon N is equal to 2 here. Logarithm of H2 concentration upon H ion concentration to the power 2. So 0 minus 0.0591 upon 2 logarithm of 1 upon this value is equal to 10 to the power minus 10. Yes, do let me know if do you find any problem here. Yes, do you find any problem here? Everything is clear? Okay, fine. Yeah. Everybody, please. If you find any doubt, you please ask me. See here, the thing we have solved it like this. Till this point, I solved it. Remaining is just a simple calculation. Right. So these are the questions, very important question, how to convert the values during the pH value. Okay, now calculate the K equilibrium. K equilibrium. Let us understand here what is the meaning of the K equilibrium here. When I say the Nernst equation is equal to E cell is equal to E naught cell minus 0.0591 upon N logarithm of product upon reactant. Product upon reactant, right? You know, this value, product upon reactant, is called as the equilibrium constant, K equilibrium. And at the stage of equilibrium, the cell will not work. This value will become equal to 0. So 0 is equal to E naught cell minus 0.0591 upon n logarithm of K equilibrium, right? Or we can say E naught cell minus is equal to negative value of 0.0591 upon n logarithm of K. Negative value cancelled, and now E naught cell is equal to 0.0591 upon n logarithm of K equilibrium. Getting me? Yes, everyone. So this E naught cell value is already given to you. Find the K equilibrium. That's it. Multiply and then take the antilog. You can get the value. Nothing more to be done here. Let me know if you have any doubt. Yes, yes, students. Please see the solution and do let me know where are you getting stuck. N is equal to 2. Yes. N is equal to 2. In the previous equation also, N is equal to 2. See here. Yes, N is equal to 2. Everyone getting me? Right. Okay, now. Calculate E cell at 25 degrees Celsius. The concentration is given here. So, writing here, first of all, I am finding out the E naught cell value. Right? And before I calculate the E naught cell value, I can see here that zinc 0 2 plus 2. It means zinc is undergoing what? Oxidation, and hydrogen is undergoing reduction. So at anode, oxidation takes place. Zinc is converting into zinc 2 positive ion, right? And at cathode, H positive ion are gaining electron and becoming H2. Right? So now E naught cell value is equal to E naught of the cathode minus E naught of the anode. What is the cathode here? Hydrogen. Anode here is zinc. Zero minus. You know the reduction potential of the zinc? Minus 0.76 volt. This value will be given to you along with the question. Here it is not given here. So the E naught cell value is 0.76 volt. Till this point, any doubt? And now we have to find the E cell value. So E cell is equal to E naught cell minus 0.0591 upon n logarithm of product upon reactant. E naught cell value is coming out to be 0.76. 0.0591. What is the n value? What is the value of n? 2. Logarithm of zinc ion concentration into hydrogen pressure upon H positive ion to the power 2. Let me know if you find any doubt here. See, in the product we have two things. Right? Then you have to just substitute the value and solve it. No, yes, we cannot. Yes, we can take 0.06 is very close answer. Yes, we can. Now, all the value to be substituted and then solve it. Are you getting me? All of you getting me? Yes. Then put the values here and solve it. Right? That's it. See. Yes, any doubt here? No doubt? Okay. I'm giving you enough practice here. Now, I discuss about the concentration cell, electrolyte concentration cell. This is a new type of cell now. Consider, here I have zinc sulfate and zinc rod is here. In another beaker, I have a copper sulfate and copper rod is here. Then the reaction is possible between the two or not? Reaction is possible or not? Yes or no? Is the reaction possible here or not? Yes. And now I am considering, let it be, here I have again the same metal of zinc and solution is zinc sulfate. Will the reaction take place here? Will the reaction take place? Yes. No. Can you tell me why? Can you tell me why? Why will the reaction not take place here? No displacement. That's not an appropriate way. Yes, anybody, please tell me, if I say both the metal in the two half shells are same, will the reaction take place or no? Anirudh says no. Anirudh, justify your answer, why not? Anirudh, justify, why not? No potential difference. Very good, Yash. Good. It means I should say E0 cell value is equal to E0 of the cathode and E0 of the anode. Both the values are same. The reduction potential of the zinc minus the reduction potential of the zinc, right? Both are the same value, it will come out to be equal to 0 and the cell will not work, right? This is the thing that you want to convey to me, right? But I'll make it happen. See the magic of chemistry now. If I change the concentration, let it be C1 concentration here and C2 concentration here, different concentration now, then the cell will work. And such type of cell is called as a concentration cell. Such type of cell is called as a concentration cell. When the two metals are same, means in the oxidation half reaction and reduction half reaction, the metals are same, but their concentrations are different, then the reaction will be spontaneous. Such type of cell is called as a concentration cell. The cell is working due to the difference in the concentration, but not due to the difference in the potential difference. Are you getting me? I'll now prove it. How is it possible? For that, wait. Just a minute. See, suppose I am putting here metal M undergoing oxidation here, double bar, the same metal line. I can say its concentration is C1 and its concentration is C2. Getting me? Now, at anode, metal is changing into metal N positive, having concentration C1 with the loss of N electrons. At cathode, Mn positive ion having concentration C2, gaining here N electrons and becoming M here. So, if you see here, electron can be cancelled, metal can also be cancelled. Same metal is here. And now Mn positive having concentration C2, Mn at a C1, right? So E cell is equal to E naught cell minus 0.0591 upon n logarithm of C1 upon C2. Are you getting me? C1 upon C2? Product upon reactant? Yes, students. Are you getting me? Right. Hello? Getting me? You don't participate effectively. You're sleeping. Yes, students. Hello? Yes, students. Okay. Neha, is this thing is clear? Please say yes, no, something like this. Is this thing is clear? First thing. Right. I can now represent this cell in the two reaction. One is the oxidation half reaction, other the reduction half reaction. Now this is clear. Clear or not? Yes, Neha? Two metal rod are in different amount. That will not make any difference. That will not make any difference, Yash. Either the metal must be different or their concentration should be different. Right? Metal amount will not make any difference. Means if I say 10 gram in one side and 20 gram in the other side, that will not make any difference. That is just a medium of conductance. So this is now clear up to this point. Yes, Neha? Okay. So this is also clear. So this is equal to 0. So I say thus E cell is equal to, this I'm putting here 0, means 0.0591 upon n logarithm of C1 upon C2. Now I'm making this negative to the positive value and writing like this 0.0591 upon n logarithm of C2 upon C1 is equal to E cell, is equal to E cell. And cell will be working only when C2 is greater than C1. The cell will be working only when C2 is greater than C1. It means the element that is undergoing reduction, should be having higher concentration as compared to the other one having lower concentration. Such type of cell is called as a concentration cell. Yes, let me know if you find any doubt here, any problem. Yes, students, do you find any doubt here? Okay, fine.